want you to remember for binomial distribution is bins. B stands for binary. Can we have possible outcomes as like success or failure? I stands for independent. They must be independent. One does not affect the result of the other. N stands for number. And the number number of trials, not trails, must be fixed. Can't do it forever. You're going to be doing this 10 times or 100 times. Success is for S. Must be the same probability for each one. So let's just decide at first, is something binary or not? Because there's formulas on the formula sheet that we're going to be looking at, and it says right before that only can be used for binomial distributions. So I'm going to put two different problems here. We're going to do just saying yes or no. For binary or not, or binomial or not. For A, let's say we're going to shoot a basketball. "20 times from different places on the court. Let Y equal the number of shots made." So let's go through bins. B, binary. Do you have a way to decide if something is successful or to decide if they're not successful? So if we're trying to see the number of shots made, a success would be the shots made. How could you see if they failed something or your failures? If they did not make the shots. Independent. If they shoot one for one, the next one, will they make it or not make it? They have the same probability. It depends on whether the person is good, or in their probability will be higher, or if somebody has a poor shot and they might not make any. But each one is going to be independent of the others. Is there a fixed number of trials? Yes, we're going to be doing this 20 times. So yes, it's a fixed number. Success is the probability that the person's going to make it the same. The probability is going to be the same because it's going to be the same person that we're going to have shoot this basketball. If Michael Jordan were to be shooting the basketball once and then I were to shoot it the next time, the probabilities are going to be different. But if we have Michael Jordan shoot it each time, his probability is going to carry over. So, yes, this is binomial. Let's try another example, something like this. Observe the next 100 cars that go by, and let's see equal color. So let's go through bins again. Can you tell if something is successful or something is not successful? What are we even looking for? We can't really tell what is a success. Are we looking for blue? Because then we could see the successes would be the blue cars and the failures would be everything else. But since we don't know that, it fails this. So I already know it's going to be a no. But there's actually another reason why too. Independent, each car would be independent of the others. How many times are we going to do this? We're going to look at 100 cars. Is the probability the same? The probability of the cars going by are okay, but I don't really know. I guess we have an equal probability of each one coming out. But there's one big problem. C needs to be a number. A quantitative amount so that we can measure it. Like before, we were measuring the number of shots made. For here, color would be blue, red. Well, there's too many things, and none of them are numbers. So, another reason why it fails.